So this is example 4 on your worksheet. I don't know if this specific problem's on there, but anytime we're solving equations using powers and radicals, you start sometimes getting what are called extraneous solutions. And extraneous solutions means they're like extra solutions. They're ones that won't work. So not only have you been, you've had to deal with now like solving for equations, now you have to figure out if they actually are giving you the correct answers, which just implies you have to check your work, which a lot of us just skip over that. Okay? So when you raise each side of an equation to an even power, extraneous solutions may occur. Make sure to check your answers. So you should always check your work. I see, like as I'm grading tests and quizzes, I see some of you who go through and you put check marks by your work, like you've checked it a couple times. You know, Santa Claus checks his list twice. You wanna be as good, even better than Santa Claus. It's good stuff, dude. Check your work. All right. Okay. So let's go ahead and solve this. First thing, get rid of the radical. How do we get rid of it? We square both sides. Now be careful when you square both sides. Okay, when I square this side, it just cancels the radical. That's x plus 7. And when I square this side, I now have x plus 1 quantity squared. This is not x squared plus 1 squared. Right? Remember, x plus 1 quantity squared is the same thing as x plus 1 times, that's a bad looking 1, x plus 1. All right? The same thing there. Good on that? So x plus 1 quantity squared. Many of you can do that in your head now. You're getting, you square this one. A lot of you make the mistake and you just put your answer as this, which that's partially right. It's just you're missing your middle term, which is just that times that doubled. So the middle term is 2x. Now if you can't do that, it's x squared plus x, and then plus x plus 1, and you get x squared plus 2x plus 1. All right? But if you can do it in your head, and I'm expecting that some of you can do that now in your head, great. If you can't, multiply it out like that. Don't go, well, they can do it in their head, so I have to be able to do it in my head, and then you mess them up. That's not good. Okay? Eventually you'll get the pattern down and you'll be able to. Okay? Next step. You have a quadratic. You have some x's. What should you do? Subtract 7. So really, we want to set a quadratic equal to what? 0. So you really got to move this 7 in. You have to move the x, right? So I'm going to subtract both of them. Subtract x, subtract 7. Those pieces are now gone. I left with 0 over here. And on this side, x squared plus x minus 6. Okay, now I'm going to pause there. I want you to make sure your neighbor understands what's going on. Now, you guys, let's make sure, I just want to make sure we're clear. It's easy for you to go, yeah, I follow all those steps, but let's make sure you understand why we did this, right? We got to here, you multiplied it out, you end up with a quadratic. Why did I move this? Like, what cued me to move this stuff over to there? Hannah?
Because you needed to set the quadratic equation to 0, and in order to do that, you need to move that over.
Good. Most of the methods we use to solve quadratics is to set it equal to 0. Now, there's one that isn't, right? What's the one we don't set it equal to 0 on? Okay?
Completing the square.
Completing the square. Okay? Completing the square, you could have left the 7. However, maybe, a lot of students don't like to use it. Though I'm grading your tests, and a few of them I'm done with. I started actually grading one by one, and then I stopped doing that and started grading problem by problem. So it's kind of awkward the way I've graded them. But anyway, some of you really like using completing the square. You did it quite a bit on the test. All right, pretty good stuff. If you can utilize it. If you can't, that's okay. Use quadratic formula or factoring. Can I factor this?
Yeah.
What does it factor to? X minus 2, x plus 3. Now, for those of you sitting there going, huh? That's a bad thing at this point because you should know how to factor now. And this is an easy factoring problem. Two things that multiply to make negative 6, add to 1. Okay? So I expect that you can factor. We spent a whole chapter on it. We reviewed it. For those of you here this summer, we'll quickly review it in a very, very fast fashion again in chapter 8. But you have to use it a lot in chapter 8. You're going to have to use it a lot in this chapter. Okay? So if you're struggling with factoring, you need to go back, maybe watch some of those videos from chapter 5 when we talked about factoring and Lizzie's method, and then get some help from me if you need it. Okay? Answer here is 2 and -3. We said each of these equal to 0, right? So we're saying, really over here, we're saying x minus 2 equals, not 2, equals 0. And so we solve that and get 2, and we're saying this one equals 0. Solve that and we get -3. Okay? So my solutions, x equals 2 and -3. Now that seems all fine and dandy. My brackets there didn't look all beautiful, but okay. However, and if you leave it like this, you've got half of it right in this problem. We raise to an even power here. Whenever you raise an equation to an even power, you could get extraneous solutions. Doesn't mean you will, it means you could. So we test them out, and it's just a quick test. Just put 2 in. 2 plus 7 is 9. Root of 9 is 3. 2 plus 1 is 3. That one worked. It's just a quick check. -3 plus 7 is 4. Root of 4 is 2. All right. And -3 plus 1 is? -2. That is not an accurate solution. That one is extraneous. We cross it out. X equals 2, and now we're done. This is an imposter. All dressed up, thinking it's cool and stuff. Now, the key is usually the ones that are extraneous, not always, but usually the ones that are extraneous are your negative ones. It's not always the case. You need to test even the positive ones because it depends what your equation looks like. But, okay? Any questions? All right. Yeah?
So, if you, like, for the -3, you just plugged it in and then they weren't equal to each other, so it was extraneous?
Correct. Yeah, because we got on this side, when we plugged -3 in, we got a 2. When we plugged it in over here, we got -2. So 2 is not equal to -2, therefore it's extraneous. Good question. Other questions? All right. Hey guys, your questions are huge, right? You understand why that is? Like, how many of you have done something a lot of times? You're very good at it. You feel like you're pretty good. How many of you have had to teach that to someone else? How many have had to teach it to them a lot of times, like to a lot of different people a lot of times? Once you teach something a lot of times, no matter how decent you do at it and how good you know it, eventually you start leaving out little pieces because you know it, and sometimes you forget maybe how to emphasize little things like me leaving this out. Okay, that's a big thing. Some of you may have just said, okay, it's extraneous, I'm done. It's extraneous because these two things do not equal each other. That's huge. Okay, make sure you ask those questions, those clarifying questions. It helps out. So let's go through a few of these. Number 21 and 22 on your assignment. All right? I want you guys to give both of those a go. Put them in your notes. Work together on them. Check out 21. You guys, like I've said earlier in class, I always change my radicals to exponents. Now, you didn't have to do that, but rather than having the cubed root of that, I'm going to put it in parentheses and say it's all that to the 1/3 power equals 5. Now, if you didn't do that, that's okay. Okay, many of you just look at it and you go, well, the opposite of cubed rooting is cubing, and that's fine. I just like to show that, hey, really, to make this power equal 1, I cube both sides. Okay, now it's not really multiplying 3, it's just to the power of 3. Right, that's a little caret symbol. But anyway, we get x minus 2 on this side is equal to 125. Now we made it that far? Add 2, we get x equals 127. Now we get one answer. You should still check it. I mean, 127 minus 2 is 125. The cubed root of that is 5, so we're good. Okay. No extraneous there. All right, first step on number 22. Subtract 5, so we get 3x to the fourth. We subtract 5 from 53, we get 48. Next step,
Divided by 3.
divide by 3, we get x to the fourth is equal to 16. Next step, take the fourth root, right? Or raise it to the 1/4 power, right? That makes this a power of 1 now. Okay? Isn't that a book? Power of 1? You think so? All right. Anyway, x to the 1/4 power, or if you want to think of it like this, that's the fourth root of 16. However you want to think of it, whatever's easier for you. Anyway, what number times itself? 4 times makes 16. It's 2.
Wouldn't it be plus or minus 2? So
Yeah.
you impose the root?
Yeah, very good point. So when we impose a fractional power here and the denominator's even, or if we impose an even root, it has to be plus minus. Now, here's my concern with this. I have said this so many times in this class, and I'm grading your tests, and I am getting sick of circling the place in front of that 2 because students didn't put plus minus. You lose at least a quarter of your points. The most you could ever get on that problem then is a 75%, if not half of the points depending upon the problem. Okay, you need to get that plus minus. Anytime you put an even root, an even index, an even root, 2, 4, 6, 8, 10, and so on, okay, it's a plus minus. All right, now how many of you know you made the mistake on the test? Okay, I would say at least a quarter of the Trig students that I'm teaching between your class and the other class made that mistake at some point. And some of you only made it once, and then the next problem you put plus minus. All right, let's not do that, right? Yeah.
So with the regular square roots, even though there's not 2 in front, you just suppose that there's a 2?
Yep.
Okay.
Yeah. All right, so it's plus minus. We test it. We throw it in. Did we rate? Now, remember, your extraneous solutions come when you take and raise something to an even power. Did I raise it to an even power? No, I raised it to the quarter power. That's not an even number. Okay, even though the denominator's even, but it's still always good to check. Okay, 2 to the fourth is 16 times 3 is 48 plus 5 is 53. Negative 2 to the fourth is that negative 2 times negative 2 times negative 2 times negative 2 is positive 16, so it's going to work out the same. All right, any questions on those two? 24. Give it a go. Okay, pause for a minute. Make sure you've made it that far. Remember, x minus 2, quantity squared is x minus 2 times x minus 2. Okay? How many got that far? How many did this part in their head? All right, cool. Set it equal to 0 because, oops, sorry, you made it that far with the squared because it's quadratic. Subtract x, subtract 1. Okay, 2 things to multiply to make 3 and add to negative 5. Anything?
I don't think so.
No. That's when some of you are like, what?
We have to do the quadratic formula.
Hey, you gotta do something else. I mean, opposite of b. I'm gonna use quadratic formula. The reason I'm not using completing the square is because this is an odd number. So when I cut it in half, it's gonna give me a fraction, and I don't want to deal with it. Okay? So, quadratic formula, opposite of b, plus or minus, square root of b squared, minus 4 times a times c. That whole piece right there is negative 12 all over 2, eh? 5 plus minus root 25 minus 12. 25 minus 12 is 13 over 2, which gives me 5 plus root 13 over 2. And 5 minus root 13 over 2. Now, let's look at our original problem for a minute. And you could put the plus minus. I separated it there because one of these is extraneous, or could potentially be extraneous, or both, I guess. But I'm taking the root of a number, and I'm adding it to 1. Okay? So if I do that here, and I calculate this piece out, what's 5 plus root 13 over 2? 4.3, thank you. And 5 minus root 13 over 2?
2.4.
6-ish.
Oh,
Let's go to the 10th there, okay? That should work out. So if I put this in, if I put 4.3 in for x, okay, 4.3 plus 1, that's root 5-ish. Okay, so this is about root 5.3. All right, and I put 4.3 in here. Notice I didn't even calculate anything out. 4.3 minus 2 is what?
Negative 1.7.
No. Yeah, it's about 2.3-ish, right?
Yep.
All right, 2.3-ish. The question is root 5.3 about 2.3? And my answer would be, yep, it's pretty close, because I know root 4 is 2. Okay, we're pretty good. This one I'm going to say is okay. 0.6, we put it in. 0.6 plus 1 is? 1.6. 0.6 minus 2. Yeah, it doesn't even matter. It's negative, right? It's negative something, which means it's not positive, which means it's not equal. This one's a positive. This one's a negative. This one doesn't work. The answer is right here. Messy? Yeah, dude. Gets a little messy. Gets a little intense. Kind of like tenting or camping there. Yeah.
Do you want us to write down the answer in like the quadratic form or not?
Right here.
Yeah.
I want it in the exact form. Okay, unless it says round, I want it in the exact form.
Okay.
And when you test it though, it's easier to test the decimal, right? Okay. Any other questions? All right. 25. Sorry. You got to do these. These two are way important. Importante. Yes. Worked out 25. How many were done before you even started working? Okay, I want you to just ignore this thing for a minute. And I even want you to ignore this thing for a minute. What does that say?
A positive equals a
It
negative.
says the square root equals a negative. Is it possible?
No.
There aren't any real answers that make a square root negative. Right? In order for this to be true, you'd have to have an imaginary solution. Correct? We're done dealing with imaginary solutions for now. We're not going to write things out in complex form any longer. This is not possible. Now, if you worked it out, so if you're like, I didn't see that, so look, and I've went through and I've actually squared both sides. I get 2x plus 1 equals negative 3 squared. Now, here's a quick error piece. Those of you who go, McCoy, I put negative 3 squared in my calculator. Well, first, there's a problem. You put that in your calculator. But if you did that, okay, if you put that into your calculator, and then you're going, my calculator's broken. It's giving me negative 9. Well, I'm glad you're thinking, because obviously it's not negative 9. It's not your calculator's broken. It's that you didn't put parentheses. So your calculator's reading it as 3 times 3 times negative 1, rather than negative 3 times negative 3. Okay? Hopefully you're not putting that into your calculator. 2x plus 1, 2x equals 8, x equals 4. We put 4 in. Okay? Well, you're going to get a positive answer in here. 8 plus 1 is 9. Root 9 is 3. 3 does not equal negative 3. It's no solution. This is not possible. Okay? All right, now you could have figured that out right away if you look at root doesn't equal negative. But if you go through the work, then you just gave yourself a little extra math work, and that's good. Okay, what's the first step in 28?
Can't see it. That would help.
Cube both sides. Okay, that cancels that. We get 2x plus 1 equals negative 3 cubed. What's negative 3 times negative 3?
Negative 27.
Negative 27.
Yeah, negative 3 times negative 3 times negative 3 is negative times negative is negative, or negative times negative times negative is negative. Negative 27. Okay, 2x equals
28.
28, yes. Thank you. And x equals
Negative 14.
negative 14. We test it out. 2 times negative 14,
Negative 28.
negative 28 plus 1,
Negative 27.
negative 27. Is the cubed root of negative 27 negative 3?
Yes.
Yeah, can a cubed root equal a negative? Yes. An odd numbered root can be negative. An even numbered root, and remember, this is implied square root, okay, cannot be negative. Right? You don't get real solutions, you get complex ones. Okay? That's okay, not okay. We good with that? This is our solution. Oops. Okay. Questions? Alyssa?
So for number 25, would you just write no solution?
No solution, yeah. Assignment, mixed side 1 through 10 and 31 through 42. 1 through 10 and 31 through 42. Now I'll tell you, tomorrow we will be covering and reviewing all the rules of exponents. Okay? All the rules of exponents. And in fact, let me just give you the preview of the assignment. Your assignment will be something amazingly cool that looks like this. Okay, you get all that fun stuff. All right? And then we're going to do some fun stuff on the back. Now, I'm not saying you get every single one of those, but you will need to know how to deal with exponents this chapter. So, those of you that don't do this assignment tonight, you're like, well, I'll just kind of spend a little on the weekend. It's okay, but you're going to have exponents that you're working on tomorrow in class, and you're going to get behind. You don't want things to start piling up this chapter. Please trust me on that. Okay? Your portfolio page is ugly this chapter. All right? Not to bum you out, but I just want you guys to stay up with your work this chapter, please, if you're falling behind last chapter. Okay. As for